just not equal. If they had said something like, we're trying to see if this is less than the average we thought it was going to be, or if they had said, we're trying to see if this is more than the average than we thought it would be, then we would start using our inequalities. But since it just says, is it? It's that like, well, it could be greater, or it could be less than. We really just want to see, is it not equal? Two-tailed. So keep that in mind, because it's an either or situation. Okay, so let's go forward and run this test. Since we have data and we have to input all of this list of data into our calculator, we have to go to a spreadsheet. We always start with a new spreadsheet. So what I do is I go to Home, I go to New Document. So I just press the number 1, but you could also press Enter. And it'll ask you if you want to save the previous document. No, you don't want to save the previous document. And then I'm just going to add in a spreadsheet. Do this every single time you have a new problem. I am now going to enter in this data just into one column. Once you've entered this all into one column, we follow our calculator steps that you wrote earlier. We go to Menu, we go to Statistics, we go to Stat Tests, and this is a one sample t-test, so we're going to just choose the t-test, number 2. Because we've been given data, we select data. Notice if I scrolled to the right, it offers me stats. So when we go later, we'll choose stats. But since we've been given data, we choose data, and we're here. Mu0 is our average that we expect it to be, right? So that's 34.5. The list where we put all of our values was in column A. Frequency is always 1, because you don't want to say that we've had like 20 of these numbers show up. And then our alternative is that it's not equal, so that our current average is not equal to the average that we established up there. If I scroll to the right, notice you have all the other options, that our current average is greater or our current average is less than, but we want it to be not equal, so we're good. It's okay if the results go in B, and it doesn't ask us on this guy about pooled, so we're fine. We just look to see, hey, is it asking about pooled? Because sometimes it does, depending on the test you run. Okay. We don't ever use the t-value because we don't get a critical value. That's only a chi-squared thing. So we can write down the t-value if you want, and it's always better because you might get like a method mark for it or some partial credit. I think it would be worth it. It takes 2 seconds, unless you're trying to write around a calculator. Negative 1.53. Okay, and then our p-value, you can see, is 0.161. Okay, so now we can draw the conclusion for our test. We say that we're testing this at a significance level of 5%. So we're going to take our p-value, comparing it to 5%. We can see that if we add on an extra 0, 50 compared to 161, 161 is greater. Since p is high, we fail to deny. Which means essentially we're accepting the null hypothesis, which is that the average of our sample is equal to 34.5. So we can say that our sample does come from a normal population with a mean of that. Okay. Now, I wrote down more than what I was asked to write down. It just said to test it, right? So this right here, this first part right here is considered your reason. So that would be like an R1 of reasoning. Or so if they said, give the answer and a reason, this would be your reason, since the p level is greater than your significance level. This is the answer, failing to reject or reject, and that would be an accuracy mark. All of this is an interpretation, and it could be an accuracy or it could be a reason. It's probably an accuracy. So if they ask me to interpret the conclusion in the context of the problem, then that second sentence would be your interpretation. But if they just said, state the conclusion of the test, give your reason, you really only need that first sentence where the reason is first and then the conclusion is after that. So just so you know what these exams might be looking for, depending on how many marks there are and how they phrase the question. I think it's best to always just put all of it if you have time, if you feel confident, because you might lose a point if you don't catch that it says interpret. That's all we're going to do for one sample t-test. We only ever do one sample t-test when we're given data. We don't worry about being given statistics. So from here on out, we're going to talk about two sample. Two sample is what we're going to see for the most part in this class. It's obvious to spot because you're given 2 rows of data. So just like with our test for goodness of fit, we had frequency, right? Like our table was like categories and then frequency within those categories, versus a test for independence was 2 separate types of categories being compared together. This is 2 samples on 2 separate rows. So I don't even have to read a problem when I'm going through all the hypothesis test questions to know whether or not, or to know what type of test goes where. So if you start really honing in on the visuals of the type of table that you get with this type of hypothesis test, it might help you even more be able to choose which test to use where. As we talked about earlier, we use t-tests a lot when we're talking about medical procedures. If we're trying to test whether or not a medical procedure has made a difference in something. And so, or in psychology, if you're like having 2 samples and you have one, what is it called? The sample that like you don't do anything with, the like unbiased sample. There's a word for it, I'm sure you know. You have the like control group. So you have the control group where you like don't do anything with them. And then you have this other group that you like do one thing and you're trying to see if the average of their results are different or not. So this is a very, very common test to be using. Here it says that we want to test a new antibiotic cream and we want to see whether the cut heals faster than the existing treatment. And so notice that in the text, because we're going to write down our hypotheses, in the text here, it says heal faster. So that tells us about our alternative hypothesis. If I establish my new cream to be mu sub 1 and my old cream to be mu sub 2, it doesn't matter which one is which as long as you are consistent. It's why I write it down at the beginning, is to make sure that I keep it consistent in my thought process. So little helpful hint there. If we say that the new antibiotic cream will heal faster, then the heal times will be smaller. A little tricky, but keep that in mind to try and think through it as you're writing out these things. So the heal time for the new cream, they think is going to be less than the heal time for the old cream. And so that's how we're taking the wording of the problem and turning it into an alternative hypothesis. Of course, the null hypothesis is always just equal, that the heal time is equal between the 2 samples. So then alternative is that the new cream heals faster, so less time than the old cream. So we've been given a list of data and we have our null and alternative hypothesis. So we can now just go ahead and run the test. So since we have a group of data, we are going to put that into our calculator in a spreadsheet. So we're going to make a new spreadsheet by going to New Document and then saying, no, I don't want to save that. And then you're going to make a spreadsheet. We're going to type in all of this data. And once you've typed it all in, We run the test. 2 sample t-tests, so it's just 4, 4, 4 all the way across, which is kind of fun. It's data that we've been given, not statistics, so we're good. List 1 is mu1, so just that's why we're labeling it here. So mu1 was in column A, mu2 is in column B, frequency is always, always 1. Alternative, in this case, we have to scroll to the right, scroll down, so it says mu1 is less than mu2. Pooled is always yes. First results in column C, that works for me. And we run the test. T-value, negative 1.77. P-value, 0.0451. We're running it at a 5% significance level. I want you to go ahead and tell me what the result is. So if we wanted to match up decimal places, putting a bunch of zeros until we match up how many decimal places? 500 compared to 451, 500 is greater. This means that our P is low, so we reject the H sub O. This means that the heal time, right? So that means that we're going with the alternative. Heal time is less than the old heal time. This means that the new cream shortens